Hello. Hello. In this video we're going to look at finding the x, y coordinate associated with a certain rotation, and the idea is the x coordinate is really just the length of the adjacent side of the right triangle that's formed, and the y is the opposite side of the triangle that's formed. So here's the question. Suppose you have an arc length that lies on a unit circle, and so of course the formula for the unit circle is x squared plus y squared equals r squared, but here r squared is 1, so it's understood that r is 1, right? The square root of 1, it's 1 squared is 1. All right, and then start at the point 1, 0, so that means you're starting at 0 degrees or 0 radians, and terminating at the point xy. It's just a general point xy. Then they say, we'll use a calculator to find the approximate coordinates for xy, and then they give you this hint. And they say, well, look, cosine, you could say that x is cosine of s and y is sine of s. And they give you what s is. S is 1.1. All right, so the first question I have is, what is s? And how's it measured? So, pause and think about that. So what I would say here then, where is s? Where is it? Where do you see it? Well, I see it here in the hint, actually. They tell me that cosine of s is x. Well, anything that is an input to a trig function is an angle. Period, end of story. Trig functions only take in angles. They can't take anything else. So therefore I know s is an angle, and then I also know how it's measured because I don't see degrees, minutes, seconds, or anything like that. I don't see any kind of notation, so I understand that it's radians, right? If it's not written, it's radians. So I know that s is an angle in radians, all right? Now, if that makes you uncomfortable, you could always say, well, we've been using theta, right? So here they could say, hint, x is cosine of theta, y is sine of theta. And let me just remind you where that comes from. Like, why can they say that? Well, remember, if you have just a basic circle on an xy coordinate system here, then remember, if I rotate, and it doesn't matter what quadrant I rotate to, let's say I always start at 0, and let's say I rotate to quadrant 2. And I have here a terminal side, right, of that rotation. What's the rule? Well, from this point on the edge of the circle, drop to the x-axis, right? That forms the right angle. So here's the radius. The angle between the terminal side and the x-axis is your reference angle. That's your theta, or in this case, s, right? And here, well, they are saying it's arc length, but remember, when you're having an angle in radians and your unit circle is 1, the arc length is the same as your rotation. So if you look at this, it's this, right? And it's also this arc length on the edge. So here, though, I'm using theta just to make it a little easier maybe for you because you're used to seeing theta. But remember, this is opposite, right? This is hypotenuse, and this is adjacent. But what do you also know it as? Well, this is the x-coordinate, this is the y-coordinate, and that's r. So remember, go back to your definitions. I know that cosine of the angle is adjacent over hypotenuse, which you know as x over r. But since r is 1, because we're on a unit circle, right? That's really just x over 1 or x. So x is cosine theta, or we could write it just cosine of s, right? Because I'm just using theta in the place of s to make it a little easier for you to understand. But that's where they got that. Of course, sine of theta is opposite over hypotenuse, which is y over r, which is y over 1, which is y. So y is sine of theta, or in this case, sine of s. I just let theta be s temporarily. All right, so that's where they're getting that, okay? Now, let me go ahead and get a fresh piece of paper. Now let's take a look at what they're actually asking you to do. I just wanted to make sure we're clear on context and what we're talking about. So if I use this formula, x equals cosine of s, and they give me s is 1.1, all I have to do is put in 1.1, and then y is sine of 1.1 sine of s. And remember, I just have to make sure I'm in radian mode, right? So go into your calculator and make sure you're in a radian mode. Right, so you come down and make sure you're in radian mode. If not, select that. I'm in radian mode, so now I can just say here, cosine of 1.1. So cosine of 1.1 radians is, and I get here 0.4, let's see, 45359. 45359. And I go that because they said go to the fourth decimal place, so that's 0.45, looks like 36. And now let's do the same thing for sine. Sine of 1.1, 0.891207, 0.891207. But here we go, first, second, third, fourth. I have to figure out how to round, right? 1, 2. Looks like the 0 rounds the 2. It doesn't round it up. Just like here, the 5, the 9 rounded the 5 up to 6. So I would enter into the software, right? 0.4536 and 0.8912. Now, one last check. Again, I want to build context so that you get more and more comfortable about what all this is symbolizing, what it's telling you. 1.1 radians. What is that, more or less? Remember? So when we say S or theta is 1.1 radians, I want to know what quadrant I'm in. Well, hopefully you've memorized that 1 radian is about 57.3 degrees, but let's just say you had and you go, okay, well, let me go ahead and just change that to degrees just so I kind of know, right? And you should be building this. So I know that pi radians is 180 degrees. So let's see how many degrees that is, right? So I would say 1.1 times 180 divided by second pi to get that in there, right? I get 63 degrees or so, you know. So hopefully what that means is you see that you're in quadrant 1 somewhere here, and that the xy of positive makes sense. Okay, and it looks like you're actually kind of higher up here, so this length x is about half as much as the y. All right. Okay, thanks so much for listening.